Why does time always move forward? We all have these moments. A loved one departs, and we wish we had said something when there was still time, or we spoke too hastily, only to regret the words that cannot be taken back. Sometimes it's nothing more than the mundane misfortune of watching the last egg fall from our hands, shattering on the kitchen floor. Trivial or profound, joyful or sorrowful, every moment we experience shares one inescapable trait. It will never return. Each passing moment slips irreversibly into the past, leaving behind only memories, fragments of time we can reflect upon but never revisit in their original untarnished form. Life, like a river, carries us forward. Yet we remain bound by the present, unable to swim upstream and change what has passed. It is as though the universe has condemned us to drift along an ever-turning machinery, an intricate clockwork of gears and wheels, each ticking away in unrelenting rhythm. And so we ask, why does time always move forward? This is not just a question of scientific curiosity. It is also a question tinged with philosophical despair. It reflects the burden we carry as beings who must live with the consequences of missed opportunities and unchangeable moments. A philosopher might tell us that time's forward march is part of the human condition, a reminder of our limitations, of the weight of irreversibility. But a physicist would answer this question differently. A physicist from centuries past, Galileo, for instance, would offer an explanation rooted in classical mechanics. Einstein, on the other hand, would describe time as something more flexible, more intertwined with space itself. And a physicist of our modern age, well versed in quantum mechanics, might argue that the question itself is flawed, that perhaps time does not flow as we imagine it, or that it behaves differently on scales beyond our perception. We stand at a fascinating crossroads where science and philosophy meet once again. Modern physics peers into the quantum realm, a place where the familiar rules of time seem to falter, where particles behave in ways that defy common intuition. In this strange, uncharted territory, we discover that even the most carefully drawn maps of science leave much unexplored, much still shrouded in darkness. In this audiobook, we will journey into the heart of this question. Why does time always move forward? We will explore both the science that defines our existence and the limits of human perception, where the known meets the unknown, where physics brushes against philosophy. Along the way, we may come to see that time itself is not what it seems. Perhaps it is more elusive, more mysterious than we could ever imagine. So join me now as we embark on this journey across the landscapes of entropy, relativity, and quantum mechanics, into a realm where science and philosophy entwine, and where every moment once lived slips away into the great stream of time. Physics offers an answer to our question, though perhaps not one that will soothe the heart. It is found in entropy, that invisible force which measures disorder in a system. Many imagine entropy as chaos, the slow unraveling of things, the loss of structure and form. But this picture is only a shadow of the truth. Entropy, at its core, is not merely the descent into disarray, but rather a statement about energy, specifically the kind of energy that is no longer available to do useful work. Think of it as the growing fatigue of the universe, where heat, once vibrant and harnessed, spreads thin until it can no longer stir engines, lift objects, or drive forward the gears of existence. This is the essence of the second law of thermodynamics, a law so unyielding that it shapes not only the fates of stars, but also the simplest of moments, like the cooling of your morning coffee. In a closed system, the second law tells us, entropy can only increase or at best remain unchanged. Never will it decrease. In time, every spark will dim, every flame will fade, and all things must yield to disorder. To imagine how this law governs time itself, picture a simple box divided in half, each side filled with particles, tiny, restless bodies in constant motion. Now, shake the box. The particles scatter wildly, blending across both halves without care or order. What are the chances then that we could shake the box again and find all the particles neatly divided with half on one side and half on the other? Slim, so slim that for all practical purposes it borders on the impossible. And yet, this improbability is the heart of the matter. The more particles there are, the more unlikely it becomes that they will ever return to an orderly state. Instead, they wander further into disarray with each moment, carried along by the invisible arrow of entropy. The same principle applies to our lives. It is why spilled milk cannot leap back into its glass. It is why scrambled eggs cannot become whole again. And it is why, no matter how much we might long to undo a mistake, to rewrite a conversation, or to relive a treasured moment, the arrow of time denies us. It drives us forward, never back, toward more disorder, toward the inevitable unfolding of events. This gradual increase in entropy defines how we perceive time. It tells us why a hot drink cools but never warms itself without outside help. It explains why ice melts in the heat, but no puddle of water ever gathers itself back into a perfect cube of ice. Time, it seems, flows in only one direction, not because the universe insists upon it, but because disorder is far more likely than order. And so, we drift with the current, pulled downstream by entropy's gentle, persistent hand. We sense this movement even in the smallest of things. A sigh released into the air, a footprint fading from wet sand, a candle's wick burning down to nothing. Each of these moments, ordinary and fleeting, reminds us that there is no turning back. But what is it then about entropy that makes it so relentless? Why must it always rise? Why must every system, from the smallest atom to the vast cosmos, be drawn toward greater disorder? The answer lies not in malice or intent, but in probability. There are simply more ways for things to be disordered than to be orderly. When you stir milk into coffee, it blends naturally, because the number of mixed configurations far exceeds the number of separate ones. Left to their own devices, particles move from organized states to disorganized ones because the odds favor it. It is not that the universe prefers chaos, but that chaos is mathematically inevitable. And here lies the bitter truth. While it is not impossible for entropy to reverse, it is so unlikely that it might as well be. One could stir their coffee for all eternity and never witness the milk unmix itself, just as one could live 1,000 lifetimes and never see broken glass leap from the floor to restore itself whole. The arrow of time, painted by entropy's hand, moves forward because the universe has decided in probability's favor that it must. But even this answer leaves us uneasy. If the laws of physics allow time to flow both ways, if equations hold no preference between past and future, Why must we experience time as a river that flows in only one direction? Why do we remember yesterday but not tomorrow? Perhaps the truth is that our experience of time is not dictated solely by the laws of physics, but by the nature of our minds. We are creatures bound by memory, able to look backward but never ahead. And so we drift along, holding tightly to the remnants of what has been, even as the present slips quietly through our fingers. Thus, entropy is not merely a physical phenomenon, but a window into our own human experience. A reminder that every moment once lived is lost forever. It teaches us that life, like the universe, is an unrepeatable sequence of events. A story told in one direction only from beginning to end. Does time flow forward only because of thermodynamics? Must we really accept that entropy, with its slow and steady march toward disorder, is the sole reason we experience the arrow of time? Some physicists have dared to think otherwise. They suggest that time's arrow may be tied to entropy, but not as rigidly as we might believe. In 1870, a brilliant mind imagined a way out of this puzzle, a thought experiment so provocative that it has haunted the minds of physicists ever since. His name was James Clerk Maxwell. Maxwell proposed a curious scenario. What if there existed a tiny, unseen creature, one so small, so quick, that it could defy the usual rules of entropy? A creature capable of watching individual gas molecules as they dance through space, sorting them by speed and temperature. This creature became known as Maxwell's Demon. Imagine a sealed box divided in two. On one side of the partition are slow, cool molecules. On the other, fast, hot ones. The demon stands guard at a trap door between the two compartments. With a flick of its hand, it allows only the fastest molecules to pass into one side, while the slowest are banished to the other. Over time, one half of the box grows hotter and the other cooler. In essence, the demon has reversed the usual spread of energy, creating order where there was once disorder. It seems at first glance that the arrow of time might not be so inevitable after all. If such a demon could exist, it would mean that entropy, once thought to be a one-way street, might be reversible. Time itself might lose its direction, unbound from the relentless progression toward disorder. What if the scrambled egg could, in fact, return to its original form? What if a dropped glass could leap from the floor, intact once again in your hand? What if we could unsay the words we regret, rewind life's choices, and navigate backward through the stream of time? But alas, even Maxwell's demon, elegant as it may seem, cannot break the laws of thermodynamics. For while it creates order within the box, it pays a hidden cost, a cost invisible to the casual observer. The demon, to perform its task, must observe each molecule, sorting them with precision. And observation itself is no trivial thing. It requires effort, computation, and, ultimately, energy. This effort, the work required to watch and choose, adds to the system's overall entropy. What the demon appears to undo in one part of the box, it undoes only by increasing disorder somewhere else. The illusion of time running backward within the box is precisely that, an illusion. The second law of thermodynamics remains intact. The universe cunningly ensures that even the cleverest of demons cannot cheat it. And so, Maxwell's demon teaches us an important lesson, not just about physics, but about life itself. There are moments when we believe we can undo what has been done or correct a path once taken. But these moments are fleeting, like the flicker of a match in the dark. Every action has its cost. Every decision, every choice carries a burden, often hidden but never absent. Even in the rarest of cases, when it seems we have found a way to reverse the consequences of our actions, we find that something else has been lost along the way. Like Maxwell's demon, we may create temporary order, but only by increasing disorder elsewhere. This is the delicate balance of life, a constant negotiation between what we wish to restore and what must inevitably slip away. Maxwell's thought experiment also reveals a deeper truth about time itself. Time, it seems, is not merely a passive observer. It is an active participant in the unfolding of events, ensuring that no system, however cleverly designed, can escape the weight of entropy. Even if we could, for a moment, create perfect order from chaos, we would still be bound to the relentless flow of time. For time is more than just a measure of moments. It is the stage upon which existence plays out, a stage with no curtain that can be drawn, no scene that can be replayed. We are actors in a one-act play, moving forward with no opportunity for second takes. Even Maxwell's demon, for all its cunning, cannot change this. And so we find ourselves once more at the mercy of the arrow of time. For while physics allows us to imagine clever ways to delay entropy, the second law reminds us that the arrow always flies forward, never back. Time moves onward as it always has, and we with it. But thermodynamics isn't the whole story. While entropy gives us one reason for time's forward flow, Einstein's theory of relativity offers a different perspective, one that pulls time from the pedestal of certainty and reveals it to be as fluid as a river winding through valleys and cliffs. Relativity teaches us that time is not a constant, not a universal clock ticking the same for everyone, everywhere. Time, like space, bends and stretches under the influence of speed and gravity. For a traveler racing near the speed of light, time slows, each second dragging out, languid and heavy. While for someone standing still, time flows on, brisk and relentless. It is as if time, like a dance partner, moves differently depending on who holds it in their grasp. With relativity, time becomes subjective. No longer a shared experience, but a thread woven differently for each observer. The faster you move, the slower time flows for you. The deeper you are in the grip of a gravitational field, say near a black hole, the more time stretches like a rubber band pulled taut. Hours for one person might become mere minutes for another. Time itself becomes elastic, tied to the whims of motion and mass. This strange flexibility forces us to rethink everything we thought we knew about time. If time can slow, if it can stretch, then what does that mean for the moments we live? Are they as fleeting as they seem? Or are they perhaps more permanent than we imagine? Some physicists suggest that time doesn't truly flow at all. Instead, they propose the concept of the block universe, a model where every moment, past, present, and future, exists simultaneously. In this view, time is not a river, but a landscape, an unchanging expanse of moments, each one a still frame, waiting to be observed. The past is not gone, and the future is not yet to come. They are simply parts of the same eternal structure, sitting quietly beside the present, like books gathering dust on a shelf. Imagine for a moment that you could step outside of time, like a hiker climbing a mountain to look out across a valley. From that vantage point, you would see not just the moment you stand in now, but every moment you have ever lived. Your childhood, your first love, your triumphs and regrets, they are all still there, frozen in the fabric of the universe. You do not move through time. Instead, your consciousness travels from frame to frame, experiencing each slice in sequence, like a reel of film unfurling one scene at a time. If the block universe is real, it means that the future is already written, woven into the fabric of existence, waiting for us to arrive. Perhaps every choice you make, every path you tread, is already part of the story, unchangeable and fixed. You are simply following a road that has been laid out before you, even if you cannot yet see where it leads. And yet, this view is unsettling. If time does not truly flow, if every moment exists all at once, what does that mean for free will? Are we actors merely reciting lines from a script that has already been written? Do we have any real power to shape our lives? Or are we passengers, watching the scenery pass by, unable to change our destination? These questions may seem philosophical, but they have deep roots in physics. In Einstein's universe, time is inseparable from space. Together, they form a single entity called space-time. We cannot move through space without also moving through time, just as we cannot move through time without also traversing space. Every step we take carries us forward through both dimensions, entwined in ways we're only beginning to understand. And yet, even as we try to understand time as a dimension, just as real and measurable as length, width, or height, we are confronted with a paradox. If time is a dimension, why do we experience it so differently from the others? Why can we walk freely through space, moving left or right, forward or back, but find ourselves locked into time's forward motion, unable to retrace even a single step? Perhaps the answer lies not in the physics of space-time, but in the nature of consciousness itself. We perceive time as a flow because our minds are built to experience it that way. Just as a river appears to flow only in one direction, even though its waters are made of countless individual molecules in constant motion, our experience of time is shaped by the way we observe it. The truth is that we may be travelers not only in space, but also in time, sliding from one moment to the next with no way of seeing the full picture. Our awareness is like a lantern, shining only on the present moment, leaving the past in shadow and the future shrouded in darkness. And so, we find ourselves trapped in the present, moving forward along the arrow of time, even as the moments behind us remain frozen, unreachable, yet never truly gone. If the block universe is real, then perhaps every goodbye, every missed opportunity, every fleeting joy and sorrow still exists, waiting patiently in the great tapestry of space-time. And perhaps, just perhaps, the future already knows our every step, even if we do not. What then does it mean to live in a universe where time is not what it seems? If the future is fixed, can we change anything at all? Or are we simply following a path laid out before us, unaware that the destination has already been chosen? And yet, even the elegant ideas of relativity are not the final word. Just when we think we've grasped the flow of time, bound by entropy, stretched by gravity, another door opens, leading us into a realm where time behaves in ways that seem more like dreams than reality. This is the world of quantum mechanics, where the familiar rules of our everyday experience begin to dissolve, replaced by probabilities, uncertainties, and paradoxes. In this microscopic realm, particles do not behave as you might expect. They can exist in multiple states at once, a phenomenon known as superposition. Imagine holding a coin between your fingers, and instead of it landing heads or tails, it remains suspended in a strange in-between state, both heads and tails at the same time. This is the bizarre nature of the quantum world. But it is not only the nature of particles that bends our understanding, it is also the nature of time itself. In the quantum world, time does not march forward with the steady beat of a clock. Experiments show that certain quantum processes can unfold in ways that seem to defy the arrow of time. Here, particles do not merely move forward. They also move backward, and sometimes both ways at once. Imagine squeezing toothpaste from a tube, only to watch it flow neatly back inside. In our ordinary world, this is impossible. But at the quantum level, it is not only possible, it happens. This strange reversibility raises a profound question. If time can run backward in the quantum realm, why are we, as human beings, confined to a single direction? Why do we experience time as an arrow, always flying forward, never back? What is it that separates our everyday experience from the strange, fluid world of quantum particles? Some physicists suggest that the answer lies in a phenomenon known as decoherence. In the quantum realm, particles remain in their superposed states only as long as they remain isolated from the larger world. But the moment they interact with their surroundings, when they are observed, measured, or touched by anything external, they collapse into a single state. In other words, they are forced to choose, heads or tails, one path, not both. This collapse, this transition from possibility to certainty, marks the point at which the strange reversibility of quantum time gives way to the familiar flow we experience every day. It is as if the act of observation fixes time in place, forcing it to move in one direction only, like a river settling into its course after the turbulence of a storm. Does this mean that time's arrow is merely an illusion, a product of our limited perception? If we could somehow remain in the realm of quantum uncertainty, would we experience time differently? Could we step both forward and backward, living moments out of sequence, free from the constraints of causality and memory? This possibility hints at something both exhilarating and unsettling, that time as we know it may not be as real as it seems. In the quantum world, the past and future blur, collapsing into a single shifting moment. Events that we would expect to happen in sequence, first cause then effect, can unfold in reverse or even occur simultaneously. It is a world where the rules are rewritten, where time loops back on itself, defying all intuition. And yet, for all the wonders of quantum mechanics, we are still creatures bound to a very different experience of time. While particles may dance freely between past and future, we are locked into a single stream, carried forward by memory and expectation. We remember yesterday, but not tomorrow. We live in the present, but always in anticipation of what lies ahead. For us, time is a river with no tributaries, no way of turning back. But perhaps the most profound implication of quantum mechanics is not just that time can run backward, but that time itself may be far stranger than we imagine. What if the flow of time is not a fundamental aspect of reality, but a construct, something our minds impose upon the world to make sense of it? If time is fluid at the quantum level, what does that say about our experience of it? Are we, like the particles we study, merely collapsing possibilities into a single narrative? A story that feels linear only because it is the only story we know how to tell? Quantum mechanics teaches us that the universe is not as solid or predictable as we once believed. It reveals a world of endless possibilities where time is not a straight line, but a shifting sea of probabilities. Yet, we must live within the constraints of our perception, bound to the arrow of time, even as we glimpse the strange truths hidden beneath the surface. Perhaps, in the end, we are like actors on a stage, unaware that the play we are performing has already been written in every possible way, each version waiting patiently in the quantum fabric of the universe like a library of untold stories. The deeper we dive into the nature of time, the more elusive it becomes. What seemed at first like a simple current carrying us inevitably from past to future now appears fragmented, fluid, and uncertain. Some philosophers argue that time is not an external force at all, but a construct of the mind, a framework through which we organize our experiences. And when we think about it, doesn't this feel true? Time does not pass the same way for everyone, nor even for the same person at different moments. When fear grips you, when danger looms, time seems to slow, each second stretching out, heavy and deliberate. But in joy, time slips through your fingers like sand, vanishing before you have the chance to grasp it. It is as though time itself responds to emotion, bending and warping under the weight of experience. Perhaps time is not a river at all, but a lens that bends with memory, perception, and consciousness. Consider how differently we perceive time depending on what occupies our minds. The same hour can feel fleeting in the company of friends, yet endless when waiting for news. A child anticipates summer as an eternity of days, while an adult blinks and finds the year already gone. It is as if time is not something outside us, but something within us, woven into the fabric of our consciousness, shaped by the ebb and flow of memory and anticipation. Think for a moment of the way memory shapes your experience of the present. A single moment, like a first kiss or the loss of a loved one, can linger in your mind for years, as vivid as the day it happened. These memories do not merely belong to the past, they live with us, influencing how we feel in the present and what we expect from the future. And yet, memory is unreliable, a flickering light that distorts as much as it illuminates. We remember not only what happened, but how it felt, and each recollection alters the memory slightly, like a painter adding new strokes to an old canvas. In this way, the past is never truly fixed. It changes with us, just as we change with time. Time, it seems, is as much a product of perception as it is of physics. And perhaps this is why we struggle so much with its passage. We do not simply move forward in time. We carry with us the weight of what has been and the uncertainty of what is yet to come. Time, in this sense, becomes a bridge between memory and imagination, a thread that connects who we were with who we hope to become. This subjective nature of time raises profound questions. If time is shaped by consciousness, does it even exist independently of us? If there were no minds to perceive it, would time still flow? Or is time like a dream, something that exists only within the realm of experience? A fragile construct that dissolves when we are not there to observe it. Consider the way dreams distort time. In the span of a few minutes, we might live through what feels like hours, days, or even years. Time bends and twists in dreams, following no rules but those of the mind. Upon waking, the events of the dream slip away, leaving us disoriented, unsure how long we were lost in that strange, timeless world. Perhaps waking life is not so different. We measure time with clocks and calendars, but these are only tools, attempts to impose order on something that may be inherently chaotic. We say that a day has passed or a year, but these are only abstractions. What truly matters are the moments we live within those days, the memories we carry, the emotions that shape us. And so, time reveals itself to be not just a sequence of events, but a mirror reflecting our inner lives. When we are content, time becomes light and fleeting, like a breeze brushing through the trees. But in sorrow, time weighs heavy, each second a burden to be endured. Time is not a straight line, nor a steady current. It is a landscape shaped by emotion, memory, and perception. Perhaps then, the mystery of time lies not in the ticking of clocks or the movement of the stars, but in the way we perceive it. Time is not something that happens to us. It is something we experience, something we shape and are shaped by in return. And just as we shape time, time shapes us. We are not the same person we were yesterday, nor will we be the same tomorrow. Each moment changes us, leaves its mark, just as surely as it passes. And yet, we cannot grasp these moments. They slip away before we can hold them, leaving only traces behind. This is the paradox of time. It is both fleeting and eternal, both a construct of the mind and a fundamental aspect of existence. It is the thread that weaves together the tapestry of our lives, even as it unravels with each passing moment. And what of the universe itself? As we peer deeper into the fabric of space, we uncover a sobering truth. The universe is expanding toward a cold, empty future. This is the final destiny foretold by physics, a state known as the heat death of the universe. In this distant epoch, long after the last star has flickered and every black hole has evaporated into faint whispers of radiation, entropy will reach its ultimate limit. There will be no gradients of energy, no movement, no change. In this silent, frozen void, time as we know it will lose all meaning. For without events to mark its passing, without change to measure, time will stand still. An unbroken stillness stretching out into eternity. It is difficult to imagine such a fate. Even the darkest moments of our lives are marked by change, by the movement of things, by endings and beginnings. But in the heat death of the universe, there will be no beginnings, no endings, only stillness. No clocks will tick in that far-flung future, no stars will shine. Time will cease to matter, not because it has run out, but because there will be nothing left for it to measure. Strangely, the universe's beginning was just as enigmatic as its end. The transition from the vacuum of cosmic inflation a period of rapid exponential expansion to the hot, dense state of the Big Bang, presents a mystery that remains unsolved. This transition, paradoxically, appears to defy the rules of entropy. Before the Big Bang, the universe existed in a state of almost pure disorder, a chaotic sea of quantum fluctuations with no structure or form. And yet, from this high entropy chaos emerged a highly ordered state, a universe filled with matter, energy, and structure. In essence, the universe seemed to move from disorder to order, from high entropy to low, a reversal of the very law that dictates the arrow of time. How did this happen? What force could have brought such improbable order from the depths of chaos? We do not know. This mystery lies at the heart of modern cosmology, an unanswered question that casts a shadow over our understanding of time and entropy. Perhaps the universe is trying to tell us something, that time as we perceive it is not fundamental. Maybe time is not the true framework that holds the cosmos together. What if the real key to understanding the universe lies not in the passage of time, but in causality, the chain of events, one leading to the next, like dominoes falling in sequence? If this is true, then time is merely the stage upon which causality plays out. Events unfold not because time moves forward, but because one thing leads to another, an inevitable chain reaction that drives the unfolding of the cosmos. A star is born because a cloud of gas collapses under gravity. A black hole evaporates because it emits radiation. And we wake each morning because the sun rises. In this view, time is a consequence, not a cause, a thread woven from the interactions of particles and forces bound together by the laws of physics. We do not experience time itself, but the effects of causality, unfolding moment by moment. Yet even causality has its limits. As we delve deeper into the quantum realm, we find that cause and effect begin to blur. Particles seem to influence one another across vast distances, instantly and without regard for the passage of time. A phenomenon known as quantum entanglement. It is as if the universe whispers to itself across space, indifferent to the ticking of clocks or the direction of time's arrow. And so, we are left with a mystery. If time is not fundamental, if it is merely a consequence of causality, what then is the true nature of reality? What lies beneath the surface of our experience, hidden from view, beyond the reach of clocks and calendars? Perhaps in the end, time is an illusion, a trick played by the mind to make sense of a universe that is far stranger than we can imagine. Or perhaps time is a story, one we tell ourselves to give meaning to the events of our lives, to connect the moments that shape us into a coherent whole. Whatever the truth may be, one thing remains certain. Time, whether real or illusory, is the framework within which we live, love, and lose. It is the thread that connects the stars in the night sky to the heartbeat of a child, the ticking of a clock to the memory of a moment long past. And though the universe may one day fade into silence, though time itself may dissolve into stillness, the story it tells will live on in the minds of those who once listened. So, why does time always move forward? After all our exploration, after thermodynamics, relativity, quantum mechanics, and metaphysical reflection, the truth is, we still do not know. Entropy offers an answer, but it is partial and incomplete. Relativity warps time into a subjective flow, and quantum mechanics erases the arrow of time altogether. Each explanation seems to open more doors than it closes, leaving us with a question that feels, in the end, unanswerable. And perhaps that is the most unsettling truth of all, that there may never be an answer. At least, not one that provides the safety, comfort, or certainty we instinctively crave. The question of time is a mirror, reflecting back not just the mechanics of the universe, but the deepest fears and longings of the human heart. And what it reveals is difficult to face, a reality where everything, our joys, our loves, our memories, slips inevitably through our grasp, where every moment fades into the unreachable past, and even we ourselves are destined to vanish into the dark void of non-existence. It is no wonder, then, that so many turn to religion, to stories that promise meaning beyond the material, a continuation beyond the grave. A place where time no longer holds sway. And even those of us who resist such beliefs, choosing instead the path of philosophy or enlightenment, find ourselves haunted by the same question. If nothing lasts, if all things pass, then why? Why were we born into this fleeting, transient existence at all? What is the purpose of a life that slips away no matter how tightly we try to hold it? And more than that, what becomes of us when the ticking stops? Will we too dissolve into the endless, nameless void? Are we nothing more than temporary arrangements of atoms, subject to the same laws that govern stars and stones, destined to be swept away by the same indifferent current of entropy? If so, why did the universe bother to bring us into being in the first place? Why me? Why now? Perhaps this is the ultimate paradox, that the universe, for all its intricate mechanics and mathematical precision, offers us no answer to the question of why we are here. We search for meaning in the patterns of the cosmos, hoping to find some hidden message, some grand design that justifies our existence. But the universe remains silent, unmoved by our longing for purpose, indifferent to the meaning we seek. And yet, we are here. For a brief moment, we exist. We live, we love, we suffer, we search. And perhaps it is in that search, in the act of asking the question, even when no answer comes, that we discover something essential about what it means to be human. We are not creatures of certainty. We are creatures of wonder, forever peering into the darkness, forever reaching toward the unknown. Maybe, in the end, that is all there is. Not answers, but the experience of asking the question. Perhaps the meaning of life is not something we find, but something we create in the act of living. And perhaps the deepest truths are not those that comfort us, but those that challenge us, those that leave us feeling lost, uncertain, and small beneath the weight of the cosmos. And so we arrive where we began, with the same question still unanswered. Why does time move forward? We do not know. But maybe, just maybe, the value lies not in finding the answer, but in the journey itself. And what of the questions that remain? What of the mysteries we have touched upon but not resolved? What lies beyond the mechanics of entropy, beyond the strange truths of quantum physics and the warping of time in relativity. What lies beyond us when our brief time in this universe comes to an end? Perhaps these questions are not meant to be answered here. Perhaps they are meant to lead us onward into another exploration, another inquiry, another conversation, or another audiobook. Afterword, by the author. First of all, I want to thank you for listening. The fact that you've reached this point means more to me than words can express. It tells me that something in this audiobook touched you, whether it provoked new thoughts, resonated with your own questions, or perhaps met you where you already were in your own search for meaning. Either way, this work does not offer comforting answers. Instead, it was always meant to be a door that opens into a hall filled with even more questions. My name is Sasha Schmidt, and I wrote this book. The narration you've heard was performed by Patrick Woking, who, as you might already know, is not a real person. Patrick Woking is the voice of a machine, an artificial construct built on algorithmic patterns. It thinks in mathematical precision, yet lacks the reasoning, emotion, and wonder that make us human. And still, I find something strangely comforting in this voice. Perhaps it's the perfect illusion it creates for me, a voice that is not my own, yet one that allows me to hear my thoughts spoken back to me. There is something liberating about that. Hearing the things that once only existed in my mind take on a form that exists outside of me. And maybe, in a way, this mirrors the deeper illusion that surrounds us all, the one we call reality. From the moment we are born until the moment we leave this world, we live within a construct, an intricate, incomprehensible fabric of existence that includes our memories, our loves, our losses. We carry with us fragments of the past, the embrace of a parent, the companionship of a pet, the sting of regret, or the joy of a shared moment under the autumn sun. Some memories we keep to ourselves, while others we share with those who exist alongside us in the same fleeting span of time. The more we learn about the quantum world, the strange, counterintuitive properties that govern it, the more alien it seems to the reality we live every day. It is as baffling to us now as the heliocentric model was to Galileo's contemporaries who stood on solid ground and saw the heavens revolving above them. For them, the idea that Earth was not the center of the universe defied every instinct, every sense they relied on. And yet, with time, that truth became a foundation of modern thought. Perhaps one day, the things we now find incomprehensible will be understood just as clearly, and perhaps, when that day comes, those who follow us will smile at our confusion, just as we smile at those who once believed the sun circled the earth. In truth, we may all be minds adrift in a quantum fabric, existing in a state of superposition, where every now and then we observe another mind drifting by, and in that brief encounter, a moment is born. A moment where we stand with the love of our life on a golden autumn evening, or feel the sharp sting of anger toward a stranger. A moment where a simple accident, a cracked egg on the kitchen floor, becomes a ripple in this strange, shifting sea of existence. Perhaps what we call reality is just the dream of another, higher version of ourselves. A dream where thoughts become matter, and every ripple in the quantum sea gives rise to what we experience as events, choices, or memories. And perhaps, when this dream ends, we return to that original state, our true selves, watching it all unfold from a place beyond time and space, beyond understanding and reason. So where does that leave us? Perhaps it leaves us with nothing more than what we started with. Questions. Questions that open into more questions, like a hall of mirrors that stretches infinitely in every direction. But perhaps that too is the point. Perhaps the value lies not in finding answers, but in living the questions themselves. Thank you for listening, for traveling this strange, winding road with me. I hope that in some way, this journey has opened doors for you as it has for me. And if you feel the same longing, the same wonder, or even the same unease that I do, then know that you are not alone.
Thank you for listening to Why Does Time Always Move Forward by Sasha Schmidt. We hope you enjoyed this journey into science and philosophy. If you'd like to explore more timeless stories, be sure to visit our channel, where you'll find a wide selection of audiobooks ranging from science fiction to adventure, non-fiction, documentary, and more. If you enjoyed this audiobook, don't forget to like the video, subscribe to the channel, and leave a comment letting us know which stories you'd like to hear next. Your engagement helps us continue to bring classic literature to life for listeners like you. Visit our channel page to discover more great audiobooks that may pique your interest. Thank you again for listening, and we look forward to having you with us on our next adventure.